So this is our 2023 fall semester midterm review, okay? So first thing I want to talk to y'all about is these properties for parallelogram, rhombus, rectangle, square. Both pairs of opposite sides are parallel. That's true of all of them. Both pairs of opposite sides are congruent. That's also true of all of them. Diagonals dissect each other. That's true of all of them. Now, this is where we differentiate. Diagonals are congruent. That's a rectangle and a square because a square is a rectangle, and diagonals are perpendicular. That's a rhombus and a square because, again, a square is a rhombus. Keep in mind your definitions of these shapes, okay? Because a rhombus, the definition of it is it's got 4 congruent sides, which means that's also a square. A rectangle has 4 right angles, right? So 4 90-degree angles. Consecutive sides are perpendicular, right? So if that's true, then that means that a square has to also be a rectangle, okay? So we're going to go ahead and plot these points, and then we're going to talk about what we get. For number 2, I have plotted A, B, C, and D, and we can clearly see that this is not a rectangle nor a square. The way we're going to determine whether it's a parallelogram or a rhombus is to compare the length of the sides. So what I want to do here is I want to count from A to B, 1, 2 up, and 1, 2, 3, 4 over. So that would be 2 squared plus 4 squared. That's going to be the length of AB. And we're going to take the square root of that. So that would be 4 plus 16. So that's going to be the square root of 20, right? So here we want to check then BC and see how its length compares. So this one we go 2 right and 1 down. Notice again, 2 right, 1 down. Okay, so when we talk about BC, it's going to be 2 squared plus 1 squared. Hopefully you can see that that's the square root of 5. So those sides are not the same length. Okay, so that's one of the ways that we can determine that this is definitely not a rhombus. We could compare the slopes of the sides. So when we get over here to number 3 and we plot A, B, C, D, this one looks like it's a rectangle. So what we want to do here is compare our slopes. Okay, so let's look at AB. So we're going to go up. Notice 1, 2 up. So our slope of AB is equal to 2 up and 1, 2, 3, 4 over 2 up, right? Okay, so that's going to be 1/2. Okay, then we're going to look at BC. Okay, so with BC we're going 2 up and 1 over. Okay, and this one's falling from left to right. Hopefully you can see that BC is equal to so if we go 2 down and 1 over, that's going to be -2. So notice the relationship between these slopes. If we were to multiply those two together, we would get -1, and that's how we can tell that slopes are perpendicular. When we multiply them by each other, we get -1, okay? But the other thing we could check here are the diagonals. So we could measure from A to C up here, okay, this diagonal right here. So if we do that, we're counting 1, 2, 3, 1, 2, 3, 4 up, and 1, 2, 3 over. So if we look at the length of AC, it was 4 up plus 3 over, right? So we're going to do this to find the length. That's 16 plus 9, that's 25. And the square root of 25 is 5. So that means the other diagonal here, DB, which is a straight horizontal line, should be 5. So let's count it. 1, trying to get a different color here so we can see it. 1, 2, 3, 4, 5, and it is. So DB is also equal to 5. So if the diagonals are congruent, then we know it's a rectangle. We could also compare the side lengths, and I think you can tell that the side lengths are not the same, right? But if we had to prove that, then we would do, again, our rise over run, right? That's how we would determine whether the side lengths were congruent or not. But this, we can prove that this is a rectangle because the diagonals are congruent and because consecutive sides are perpendicular, okay? So the next one says, what is the equation of the line that is parallel to the graph of y is equal to 2x minus 5 and passes through the point 8, 10? So here we need to pull our slope from the equation y equals mx plus b, recalling that m is our slope. So m is whatever's in front of that x. So m here is equal to 2. It's this parallel, so that means the same slope. So we're going to keep that slope. And then we're going to use x and y over here. We're going to put x, y, and m into the equation y equals mx plus b. and we're going to solve for b, and then we're going to put our m back in. So we're going to put 10 in here for our y. We've got 2 for our slope, and times 8 plus our b. This would give us 16 plus our b is equal to 10. So we're going to subtract 16 from both sides. So that means this is 6 is equal to b. Now we're going to take this new b and that slope and put them in to get our equation for our line. That is parallel the line with the line 2x minus 5 and pass through the point 8, 10. So this is going to be 2x plus, sorry, that's a minus 6, isn't it, y'all? Right there. So that's going to be minus 6, not plus 6. Minus 6. Because it was 10 minus 16. Okay, so this next one says, which of the following statements would prove that triangle ABC is a right triangle? So here again, let's talk about these slopes. So if we had the slope 2, what's its perpendicular slope? It would be negative 1/2, right? So if we multiplied this, a negative times a positive is a negative, right? And that would give us negative 2 over 2, which is actually equal to negative 1. So this is which of the following statements would prove that triangle ABC is a right triangle? That we had perpendicular slopes, right? So this is saying if the slope of AB right here times the slope of BC right there was negative 1, that would prove, yes indeed, that there's a right angle at angle B. All right, then it says find an equation of the line in slope-intercept form given the following situation. Okay, notice this word perpendicular, so we're going to fold the slope again here. M equals 3. So our perpendicular m is going to be equal to negative 1/3. Here again, this is x and this is y, so we're going to plug those into our equation. Y equals mx plus b. So we've got 2 equals negative 1/3 times our negative 6. A negative times a negative is a positive, right? So that would be 6 divided by 3, which is 2. So this is 2 equals 2 plus b. We're going to subtract that 2 from both sides. So we have b equals 0. So here again, we plug this in with our new slope. And you should all know that if b is equal to 0, then we're going to write nothing. So y is equal to negative 1/3 x. Okay? Number 7 says, find the equation of a line in slope-intercept form given the following situation. So here again, we're going to put this in y equals format, okay? So we're going to subtract 2x from both sides. That gives us 3y is equal to negative 2x plus 6. We're going to divide everything by 3 here. So that's going to give us y equals negative 2/3 x plus 2. Okay, so what are we looking for here? Perpendicular. So we're going to, our current slope is negative 2/3. So our perpendicular slope is going to be 3/2. And then we're going to take that x and that y and put it in the equation. Y equals mx plus b again. So that means we got 1 equals 6 times 3/2 plus b. 6 times 3 is 18. 18 divided by 2 is 9. So this is 1 is equal to 9 plus b. We're going to subtract that 9 from both sides. Minus 9, minus 9. So b is equal to negative 8. And now we are going to plug in our new b with our slope that's perpendicular, which is this one, and we're going to write the equation. So y is equal to 3/2 x minus 8. So the next question says, what's the equation of the line perpendicular to the line AB and passing through point C? So what we have to do first is find the slope of line AB. Okay, so when we do that, we're going 1, 2 up, rise, right? So this is rise over run. So we went 2 up and we went over 1, 2, 3, 4. So that's going to give us a slope of 1/2 for AB, okay? But it's asking us for the perpendicular slope here again. So that means when we are looking for the perpendicular slope, we're going to change the sign and we're going to flip it. So it's going to be negative 2. Then we're going to use this point down here, negative 2, comma 1. That's going to be my x and my y, and we're going to plug that into the equation again, y equals mx plus b. So that's going to give us 1 equals negative 2 times negative 2 plus our b, okay? So that's going to be 1 equals negative times negative is positive, 4 plus b. So now we are going to subtract 4 from both sides. So that's going to give us that b is equal to negative 3. So now we're going to write that into our equation. We're going to use our perpendicular slope in our b, our new b. So this is going to be y is equal to negative 2x minus 3. Now it says to put it in standard form. So what does that mean? That means we're going to move our x, our negative 2x to the other side by adding 2x to both sides. So this is going to end up being 2x plus y equals negative 3. Number 9 says find the perimeter of the figure below to the nearest tenth. So what we're going to do here is we are going to find the length of each side. So let's just go ahead and start with this side right here. So we're going to talk about our rise. 1, 2, 3, 4, 5. So that's going to be 5 squared plus our run. 1, 2, 3, 4, 5 again. 5 squared. And that's what we're going to take the square root of. So this side right here is going to be the square root of 50. Okay. We're going to keep doing that. We're going to keep moving around the image here. So here we go again. So this time we got 1, 2, 3. So we're doing 3 squared. 1, 2, 3, 4, 5, 6 plus 6 squared. So that's going to be the square root of 45 for that length. This one over here on the right, we can just count, right? 1, 2, 3, 4, 5, 6. So this one's 6. Again, we're going to keep moving around the image here. And I'm just going to go ahead and do this one in black. 1, 2, 3. So we got our 3 squared. 1, 2, 3, 4, 5, 6, 7, 8 plus 8 squared. So that's going to be 64 plus 9. That one's going to be the square root of 73. Got one more. This one over here. So let's count again. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So this is going to be 7 squared plus 3 squared. So that's going to be 49 plus 9. So that's going to be the square root of 58. So what you want to do now is put these all in your calculator and add them together, okay? So we're taking our square root of 50 plus our square root of 45 plus 6 plus the square root of 73 plus the square root of 58. When I did that in my trusty little calculator, I got 35.9. Okay, that's the perimeter to the nearest tenth. Remember, tenth means 1 0, okay? Or one point after the decimal. Find the area of the figure below to the nearest tenth. So the area of a triangle is 1/2 base times height. This is my base right here, and you could turn it to see that. 1, 2, 3, 4, 5, so that's 5. Remember, our height is always a right angle to our base, okay? So that's going to be our height right there. And this one's 1, 2, 3, 4, 5, 6. So this is 6. So we're going to do half of 5 times 6. So that's going to be half of 30. So this is going to be 15 units squared. Okay, so the next one says a rectangle has the following 3 vertices, and on your paper you didn't have, even like with 2 and 3, you did not have a graph there, right? But you are going to have graph paper when we take of some sort, when we take the exam, okay? So we're going to plot this point, negative 2, 3, negative 2, 3 right there, okay? And saying this is a rectangle. So all I have to do is find the length of 2 of these sides, right? And then multiply them. And then we got 4, 1. So 4, 1 is there, okay? So this is one of the sides of my triangle, right? Or of my rectangle. And then we're going to go ahead and do the other side as well, so I can show y'all what we're going to do. And then we've got from there, we got 5, 4, right? So there's our 5, 4. So this is going to be our other side, okay? So what I want to do is just find again, rise and run, right? So to do this, I'm going to go 1, 2, so 2 squared, plus 1, 2, 3, 4, 5, 6, plus 6 squared. So that's going to be 4 plus 36, so that's going to be the square root of 40, okay? Because remember, when we're trying to find the area of a rectangle, we just do base times height, right? So then we're going to do this one over here, 1 over and 1, 2, 3. So this is going to be 1 squared plus 3 squared. So that's going to be 1 plus 9, so that's going to be the square root of 10. Now what we can do with this, we can just go the square root of 40 times the square root of 10, and hopefully you remember this property. You can do this in your calculator if you don't remember this, but either way, we can take both of these back underneath there and go 40 times 10 That's going to be the square root of 400, and hopefully you know that is 20. And again, this would be units squared because it is area. All right, number 12 says, given the points of the figure MNO, after transformation of the figure, the points become M prime, N prime, O prime. Identify the transformation. So I would not use this point because it's got two ones. I wouldn't use this point because it's got a 0. So let's just take the N. So if we compare N, negative 2, 3, to our N prime, which is negative 3, negative 2, hopefully you immediately notice that they flipped, right? So it's going to be y comma x. Now, negative 2 was negative to begin with, but now the 3 became a negative 3. So what is that the rule for? A 90-degree rotation about the origin, okay? JKL is a translated, okay, now none of these answers were right, y'all, when I did it. So let's just double check me. So first of all, it says JKL is translated 3 units down, 6 units to the right, then reflected over the line y equals x. What is the coordinate of point K, double prime? So K is 4, 4, okay, and it says we're going to go 6 units down and, 3 units down and 6 units right. So this is going to be x plus 6, y minus 3, right? So what we're going to do is we're going to add 6 to the, this our k prime is going to be 4 plus 6, that's 10. And 4 minus 3 is 1, right? Okay. Then we're going to do our next rule here, which says it's a reflection of the line y equals x. So that would be y comma x, right? So when we go to our k double prime, it's going to just flip positions, right? So that was your answer right there, 110, which wasn't even one of these choices, okay? All right, so 14 says a figure has the vertices of blah, blah, blah. After transformation, the image of the figure has the vertices k prime 5, 5, blah, blah, blah. Which best describes the transformation? Okay, so here again, I'm not going to use k. I'm not going to use m. I could use l. So let's look at l. So when we go from l, which is 5, 3, to l prime, which is 3, 5, what do we notice happened? They flipped, right? So this is going to be y comma x. And what is that? A reflection over... So, KLMN. This is not the right image, y'all, for this drawing. And these are not the right answers based on what's here. So, these are two different problems. I don't know why they have two different things. So, if we look at the drawing, y'all, not the words, then this would be a rotation, right? Okay, so how do I know that? H to H prime, G to G prime. Y'all see that? They cross. So this would be this is a 180-degree rotation. However, if we look at the values that are in the problem, then the answer would be a reflection not over y equals negative x, but over y equals x, right? So this should have been a reflection over y equals x. So these are two separate problems. I don't know where that drawing came from, but there we go. All right, number 15 says, given EF is the angle bisector of DEG. So if we draw DEG, DEG, okay, and it says EF is the angle bisector, that means these angles are congruent, right, y'all? So this angle is congruent with this angle. Put our arcs on them. It says FED, that's our top angle, is 2x plus 41. And then it says FEG is 6x minus 7. So what do we have to do here? We would set those equal to each other, right? So 2x plus 41 is equal to 6x minus 7. So subtract the 2x from both sides. So that's going to give us a 4x over here, and that's now gone from there. And then we're going to add 7 to both sides. So that's going to give us 48. How many times does 4 go into 48? So we're going to divide both sides by 4 here. So x equals 12. So what did the question ask us? Find the measure of angle DEG. Okay, so I'm going to plug this into both just to make sure that my value is right. Okay. So when I look at FED, that angle, okay, that's going to be equal to 2 times 12 plus 41. That's 24 plus 41. That would be 65, right? All right, so then let's also look at angle FEG. So that one's going to be 6 times 12. That's 4, what is that? 6 times 12, 72 minus 7 is also going to be equal to 65. And when we add these two angles together, that gives us our whole big angle, right? So that's going to be our answer. So this is going to be 130 degrees, okay? So the answer was C, okay? Number 16 says, given the figure DEF, D, E, and F, the figures rotated 270 degrees after being translated after. Ooh, look at that key word right there, y'all. After, y'all see that? So translation happened first, okay? So, and it's asking us about F, okay? So F was 2, 4. It says that it was translated. So this would be x plus 4, y minus 3. So our F prime would be 6, 1, right? Okay. Then it says rotated 270 degrees. So what's the rule for that rotation? 270 degrees, there's going to be y comma negative x, right? So that means our F double prime is going to be 1 comma negative 6, right? 1 comma negative 6. So that's D. Okay. Number 17 says JKL is rotated 90 degrees about the origin, then translated 8 units left and 5 units up. What are the coordinates of the final image of point L under this composition of transformation? So we got to find what L is first, right here. Okay, so L, notice it's between 4 and 6, so that's got to be 5. And it's between 0 and 2, so that's got to be 1 right there. So that's 5, 1, that's our L. It says rotated 90 degrees, so that's going to be what? Negative y comma x. So when we do that, our L prime is going to be 1 comma negative 5. Then it says we are doing another transformation. So the next transformation is going to be what? Translated 8 units left, so that's x minus 8 and 5 up, so y plus 5, okay? So when we do that, our L double prime is going to be 1 minus 8 is minus 7, right? And then negative 5 plus 5 is 0. So that's going to be negative 7, 0. So this answer was C. Next part I'm going to go over is not on the review, but I want to remind you guys of what it looks like to bisect a perpendicular a line segment, okay? So when we do this, we are going to go more than halfway with our tool, and we're going to measure from one endpoint, and we're going to not move our compass, and we're going to do the same mark from the other endpoint. And then where those two arcs intersect, we are going to draw a line. And this is a perpendicular bisector, okay? That's what you just saw drawn. And let me run it again so you guys can watch it one more time. Okay, so again, go more than halfway, arc above, arc below, pick it up, go to the other side without changing the length of your compass, draw 2 more arcs, and then draw a line through those 2 points of intersection. The one I want to go over here is bisecting an angle, okay? So this one, again, we have our angle. We're going to draw an arc across the angle, and this could be a continuous arc here, and you don't have to move your compass at all, but you're going to go from those 2 points of intersection. You're going to draw 2 more arcs out beyond there, and where those 2 arcs intersect out here, this is what then bisects that angle, which means it takes the big angle, cuts it into 2 smaller equal angles. Again, watch it again. So here we go. We're going to create an arc across both sides of the angle. Again, this could be one continuous arc, y'all, okay? Pick up your compass and then create 2 more arcs out further in the middle of the angle. And where those 2 arcs intersect, this is what we call the angle bisector, okay?